Hi, this is Sharon Sarago here, and today we're going to do just a little review over fractions and rational numbers. This is just to be sure that you remember everything. There's a lot of students that get a bit rusty when it comes to working with fractions, and because of this, many students rely on their calculators to get through a fraction problem. You should know this is a bad idea. On the new test, the PSAT that you're going to have in October, and then the new SAT that starts March of 2016, you're going to have two sections of math. One will allow the use of a calculator, but the other one will not. You will have a section that forbids the use of a calculator. So if you are not up to snuff on this, you need to start practicing solving your math problems without a calculator. That being said, here's what you should remember about fractions. To reduce a fraction, you need to look for a factor of both the numerator and denominator that is common. For example, in the fraction 9/12, we can reduce the numerator and denominator as follows. Since we know that both of them are divisible by 3, we divide both the numerator and the denominator by 3, and we get 3/4. Of course, you could use your calculator either to reduce the fraction or to change it to a decimal. But I really want you to start doing this on your own and get used to working without that calculator. Here's an example. Megan invited 9 friends to her birthday party and wanted to evenly distribute a bag of 50 pieces of candy among the friends. If a partial piece of candy is not possible, how many pieces will each friend receive? Here are our possibilities here. So clearly it's a division problem. We have 50 pieces of candy to be divided among 9 friends. As a fraction, this can be represented as 50 divided by 9. However, if you read the problem in its entirety, you see that the partial pieces are not permitted. So the fraction 50 over 9 does not reduce to a whole number. However, we can write it as a mixed number, 5 and 5/9. The 5/9, of course, would represent a partial piece, which would have to be discarded according to the instructions. Thus, each friend will receive 5 pieces of candy. This is choice C. You could also use your calculator or your pencil and pen to just simply divide 50 by 9, and you would get 5.5. Again, once you see that, you would know you'd have a fraction of a piece which you'd have to discard, and so the same answer, each friend would receive 5 pieces. Next is adding and subtracting fractions. Here's our rule. To add or subtract fractions, you must have a common denominator. So to combine the fractions 1/3 plus 2/5, you first have to rewrite the fractions with a common denominator, and that would be 15. The way we get that is to look at the 3 and the 5, multiply them, and that will give you a common denominator. In this case, it was 15. So here's what that looks like if you were going to do it longhand. 1/3 plus 2/5 is the same as 1/3 times 5, both the numerator and the denominator, so that we can get this to 15. So we're multiplying it times 5. Then we're going to multiply the 2/5 right here by 3 on both the numerator and the denominator, so that we get this 5 to 15. Now we have common denominators. We've got 5/15 plus 6/15, and now we're able to add them, and we get 11/15. Here's an example for that. Line L1 has an equation y equals 1/2 x minus 5 and slope m. And line L2 has the equation y equals 2/3 x plus 7 and slope n. And they want to know what is the value of m plus n. Well, notice that they said that m is a slope and n is a slope. And that's going to be important for you. Just remember that the slope-intercept form of lines is y equals mx plus b. And that gives you an easy way to determine the slope of a line, because we know that this m stands for the slope. So when we look at the lines given, L1 has a slope of 1/2, that would be what that m is, and L2 has a slope of 2/3, which is what that is, 2/3. Then we can write this out, because we know that we're trying to find m plus n, slope of line 1 and slope of line 2. So line 1 had a slope of 1/2, here we go, and line 2 had a slope of 2/3, here. And now we're going to add them, but our denominators are not the same. So our first step is to get a common denominator, which in this case would be 6. So then we've got 3/6 plus 4/6 is equal to 7/6, and that's our choice E. Then we come to multiplying fractions. Remember, to multiply fractions, you can multiply the numerators together and the denominators together. In other words, we can go straight across. This is one of the easiest of all. You see 2/3 times 5/7. You just simply go straight across. 2 times 5 and straight across. 3 times 7. This is for multiplying fractions, and we get 10/21. Now that does not reduce, so that would be our answer. However, if you have one that can be reduced, don't forget to do that. Sometimes the fractions contain numbers that can be reduced from the start. On problems like this, we should go ahead and cancel factors as we are able in order to make the multiplication easier. Let's look at one. Here's 2/3 times 3/5. Well, the first thing that we see is that we could cancel the 3's here. And then we would get 2 and 5, 2/5. Here's a bigger example. Look how many we're multiplying. This times this times this times this times this. And yet, it can be very simple. Don't reach for your calculator. You should notice that most of the factors cancel except for 5a in the numerator and a factor of 10 in the denominator. Well, let's look at this again. First of all, we're going to see what we can cancel. The 6's. What else can we cancel? The 7's. And then, of course, the 8's. And now you see the pattern. We can cancel the 9's. And so what are we left with? As a numerator, we have 5b. As a denominator, we have b and 10. And so that's what we're left with. But we can also get rid of the b's, and then we can reduce. So this would give us 5a/10 once we get rid of the b's. But don't forget to reduce the 5 in the numerator with the 10 in the denominator. So our correct answer will be a/2, which is choice B. And the last one that we have is dividing fractions. When we do this, remember that we simply multiply by the reciprocal. So let's look at one. Here we have 3/5 divided by 1/2. And what we're going to do is take this one and just turn it upside down to get the reciprocal and then multiply. So the 3/5 stays the same, as you can see. And then we're going to multiply by the reciprocal. 1/2 now becomes 2/1. And in multiplication, remember that we can go straight across. 3 times 2 is 6. 5 times 1 is 5. So let's review real quickly about rational numbers. A rational number is any number that can be written as a ratio of two integers, like a/b. And of course, b does not equal 0. This simply means that rational numbers are just fractions. And don't forget that fractions can also be converted to decimals. You should know the fraction and decimal equivalents without reaching for your calculator. These are the very, very common ones. You must know these. So if you're a little bit rusty or you didn't take the time to learn these equivalent expressions, you need to do so real fast, because you don't want to spend a lot of time having to go longhand and calculate that, or spend time getting it out of your calculator. It needs to be in your head. Okay, well, that takes care of our review for fractions and rational numbers. You will have some practice problems in your printed materials. So I think you have only about 5 of them. But after you complete those, if you have any questions at all on them, mark the ones that you want to ask about. And then when we get together with our meetings, we'll take a look at them and see if we can't figure out what the problem is. Okay, I'll see you in a day or two.